What is the correlation coefficient? You got it as approximately negative 0.37. What you did is you looked right here, and this is the R, so the correlation coefficient is the R. What does that tell you about the data? It's a weak negative correlation, because remember that your numbers for the R are between -1 and 1, and the farther away they are from 1 or -1, the weaker they become. You are now going to do predictions, and if a student watched 20 hours of TV, what would be the best prediction of their quiz score? The hours is the input, so you're going to input it into your equation of linear regression, and it would be predict that they got a quiz score of 70, oh sorry, quiz score of 60. And then if a student made a 70 on their quiz, that's the output, so you're going to substitute 70 in for the y and solve for x, and it's about 13 hours. The next part is you're going to use the correlation coefficient, it's R in the calculator, to determine if a set of data is a linear function. How would you know if the data would be linear? Remember that you have correlation coefficients between -1 and 1. So at -1 and 1, they're perfect. So a -1 would be a perfect negative correlation, and at 1 would be a perfect positive linear line. So using the calculator, what I'm going to do is I'm going to copy this information. So I'm going to copy that data, going to add it to a table. I'm going to take this data, I'm going to put it into Desmos, and I'm going to get, I have created the table in Desmos, and I am going to get the expression. So this is y2 mx2 plus b, and I look at my coefficient, my correlation coefficient, and it's -1. And if you notice, this would be known as a perfect negative correlation. On here, I would say R equals -1, perfect negative correlation. I also look at my equation, and right here the slope is -3, the y-intercept is -2, so therefore y equals -3x minus 2. I'm going to now take this next set of data, and I'm going to do the same thing. I'm going to put it into Desmos. And here my information is in Desmos, and then I'm going to do the expression. So y2, the squiggle, mx2 plus b. I notice that my correlation coefficient is 1, and 1 means that it is a perfect positive correlation. My slope is 0.5, and my y-intercept is 3. Because I have decimals in my table set, I can come here and write that it is a perfect positive correlation. That's an I. and y equals 0.5x plus 3. Final example is here's our set of data. Going to bring it into Desmos. Here's the graph of it. We're going to do the line of best fit. The coefficient correlation is negative 0.4489. That means that it is a weak negative correlation. And so for an answer, we are going to say that we're going to say that R, oops, sorry about that. R is negative 0.4489, and that is a weak negative correlation. And you can tell that it is a weak negative because there's a lot of gap between the line of best fit and the data set. Please keep in mind that when doing an equation for line of best fit, that you round numbers in the line of best fit to the nearest 10,000. That means 4 decimal places, and all other numbers to the nearest whole number. What you will be doing is on 7-2 is telling me what the meaning of the coefficient and finding lines of best fit using Desmos.